You have seen ChatGPT browse your web, Cloud write your code, and Gemini book your calendars. Those are tools, not the model. If you strip away tools from model, then your AI will be trapped. So your model is basically a very intelligent, articulate system which can generate response, but at that same time, it is useless in real world, doing anything into the real world, like sending an email or basically writing your code or booking your calendar, anything. So how do you let it out? So today we'll talk about how LLM are different than agents, and what is the 5 way tools calling can be better, and what is the 4 way where tools calling can break into the production. At the end, we will also do a postmortem of ChatGPT live, so that you will be able to connect all the dots we are teaching, right? So before going further, just a disclaimer or context. So this is the second last chapter of concept section of our agentic system design course. So our overall agentic system design course is divided into 3 parts. One is concept, second is engineering, and third is interview. You can see the whole course structures on the websites linked into this description. But concept is mostly focused on overall high level agentic system, so that you have an idea what we are talking about. Then in engineering section, there will be more than 35 plus lectures, and it will be really deep, focus on small things, and it will teach how to think while taking decision, what is the mental model, and it will be a very in-depth course. In the last 2 episodes, right, if you see, we have a model where model can think better. We have talked about chain of thoughts, we talk about basically reasoning models. Then in the last episode, we also talked about how to give your custom data, which is like a RAG, right? But still there was one questions which where we left in the last episode, that it can think, it can know, but still it can't do anything, right? So we'll discuss like what is the solution for it. So let's see. Solution is very simple. Give it hands, right? Just if you see as a human in real life, or what we do, our mind just consider it as an LLM. So it process all the data, and the same time it's give you output. But at the end, it's your hands like which actually do something, right? Actually, your legs also do, but let's take it like simple. So it's hands which actually do in real life. It's actually press the buttons or do some impact, right? So what we will do, we will give LLM hands so that it can press a button in real life and do make some impact, right? So what tool is? So tool is nothing, it's just a type function that model can ask. So basically we all know about the functions from our programming things. So it's like simply a function is a set of instruction to execute a specific task, right? So the tool is a typed functions which is like having few extra parameter. We'll discuss about it. For example, it has a name, just like our function, okay, what the name and what it do. And next, like descriptions. So this is very important, that's a new, and this is important for agents. Like function come with a description that what function actually do, and this is very important. We also set like docstring for LLM to decide when to call this function. So this is very important, and there is a lot of tricks involved, like how we will actually define it. Next is argument. Just like a regular functions, we will know like what argument to pass, just like our API model contract kind of thing. And next is runtime. So basically we'll write the code, we'll also provide the runtime, which runtime is nothing but a code which actually executed. So agentic runtime is a quite interesting topic. We will discuss this about into our engineering section, but going in the further slides, we will also have a rough idea how it's look like, right? So we understand tools is a function which agent can call, right? So let's move there. So if you see how this overall work, it's work like a simple flow. For example, you have your machine, and then you have LLM running into the cloud, right? And you ask like LLM, what's the why like NVIDIA is like trending right now, right? So what will happen is LLM, it will go to the LLM will think about it, but at the same time LLM is not having information about the current news. I told you, like there was no like information about the current news. It doesn't know what NVIDIA price is, right? So it need to find out why this is happening. So it will basically call you back that, okay, I need to search for this, like can you search it? And then your machine will basically call a function like get a stock price or search or whatever, and then whatever the response will come, it basically give response to the LLM. and LLM will take that response and rewrite it in a form of answers and then return it to you, right? Okay, you might think like, Sunny, this is like too simple or might be too complex. Like, I really don't know. I use like ChatGPT and I simply ask and it give answer for me, like where this thing like sits, right? So don't worry, just hold till end. We will also do a proper postmortem of ChatGPT web, like how this work. But for now context, if you see, we are designing a agentic system. So when I say your machine, this will be like your like either lambda or your servers basically, which is like running your agents, right? And then LLM is actually the API, like Anthropic API or ChatGPT API or Gemini API. How we'll call like there are way like we will call through Bedrock or something. But in short, if you see, those are like APIs. We are not going to run LLM by ourselves. I mean, we can run. That's maybe like at the end of course we can talk about it, because that's I'm seeing in the future there might be a future of like local running LLM, but that's I will not divert myself. But right now, I'm saying your machine, this is basically the either your Mac or your Lambda where your codes are running, right? So let's move further and see like how these things work better, right? So there is name of the same pattern which is called like function calling, right? And depending upon the provider, for example, OpenAI call it like functions and Anthropic call it like tools, but it doesn't matter. For as an engineer, for us simply means it is a functions or it is a way to provide LLM a feature so that they can access the outer world or they can actually do something. For example, they can query, they can search, or they can call to send basically email, or they can do anything. And in the real world, if you heard about MCP, there is a protocol to expose that. Basically, like what everyone is doing is they're exposing their API in a form of like function to the LLM, which LLM is using it, and then they are actually doing some work, right? So now the tricky part is just giving a function or giving a hand is not enough. You have to tell it how to use them. So this is like interesting part. So if you see like in a real coding, when you write a function as a developer, we also write the logic. Basically like we are the one who is basically calling it from other functions or maybe other like anywhere else in the code. But we write the logic like in what situation we need to call. Same way, we need to provide that logic to the LLM, like okay, when this tools can be called, right? So that's we need to keep into the mind that we also need to be very crystal clear, like when we are providing the logic to LLM, like when this tool will be called. So 5 instructions that model actually listen to. So when we are defining our tools, these 5 things we have to keep into the mind. So first, like when we are calling LLM, we will also explain like who it is, like kind of a persona kind of thing. You are a like program managers, or you are a front-end engineers, like we have to define that persona. Next thing is like when we are querying it, we need to define a shape, like what to return. So what will happen is we will call LLM will ask us to run some functions, and then we'll give the response, and then LLM will actually rewrite the response and return it, right? So we need to define like, okay, what shape when you are returning the response will look like. Next thing is like, we also need to show some examples. So if you remember in the first lecture, I talked about like in context learning, right? So if this is something new you are introducing to the LLM, so we also need to define that, okay, few examples how it will look like. Next thing is like describes the button, which means like I talk about like function description, like how to call. So we need to be very crystal clear when to call that function. There should not be any conflict. For example, if there is a 2 functions which kind of having a conflict in definitions, LLM will get confused like whom to call. So we have to be very crystal clear, like when we are describing that when this function will get invoked. And then we also need to mention some cutoff or stopping things, that when it's done, like for example, after like you should not run more than 10 loops or something like that. So these are like high level concept. We will, when we are implementing actually tools, we will keep that into the mind, right? So next we can move further. So four-way like tool callings can break. So we have introduced tools where LLM can call and get the data. There is like four-way it can break actually into production system. First is like hallucinated argument. So this is very important. So if you see like what we say, it's just a function, right? For example, we expose our MCP server for database where like LLM can call and query, right? And simple thing is like it's a like select asterisk or it's a like delete user and it's pass some ID, right? But there is no way LLM can guarantee that that ID is correct. So it might just assume some ID like for example, it's a delete user ID John, but there is no Johns in the table. So we have to kind of validate that or we have to make sure there is a safety guard there that LLM whatever they are passing as a argument is right. So basically we have to take care about input sanitization part there. Next is like wrong tool pick. So sometimes what happening is like, as I told, if our descriptions of the function is not correct or it's basically ambiguous of two functions, LLM can pick a wrong tool. So when we are designing agentic system, we have to make sure that whatever tools we are giving to LLM are quite distinguished and LLM can clearly pick which one to choose for which job. So that's the one thing. Next thing is like we have to define some cutoff situations that okay, you should stop executing after 10 times, right? So that's like that also come under resilience pattern. We will have a separate kind of chapter where multiple lectures on it, like because the big problem with when we're designing LLM, it's basically run into the loop and we don't want to stuck into infinite loop where Agentic just keep thinking and next day when you woke up you get a surprise AWS will, right? So we have to define some like a stopping point that no, we should stop. For example, if you define like a search function, right? LLM search something and then it's found something else, again search something. So what will happen is if it goes into loop, I mean it can go like 100 times, but we have to just put a hard block that if you're searching something, just search it for like 5 times or 10 times and then whatever data you have, just give the result, don't go beyond that. So something like that on a higher level, right? Next thing is malformed output. So what will happen is our search is fine, but when LLM is returning you the output, that is something absurd, like that's not even reading from the like your search. So what we have to do is we also have to make sure that there is proper like output validations. There is like a, for example, we ask LLM to produce a JSON, right? So LLM get your data, write a JSON. So we can have a validator there before which can actually validate that JSON is following the right schema or not. So these are the 4 way LLM like this tools calling can go wrong. So you might ask like, Sunny, why you are telling me this sounds like a very high level things and why we are learning right now. So the thing is, yes, this is high level things. So the tricky part here is like as an engineer, there are 4 catches, but as an engineer, we have to design solution for every those catches. So right now in the concept section, I'm just telling you high level what the problem are. And then in engineering section, there will be a separate lectures on every one of it and we'll see like how we'll solve it, right? So if you see, for example, next 5 like episode or like the fixes, first it's hallucinate. So what we'll do is like there will be a proper schema and the contract. And then like if you pick the wrong tools, so we will describe like the docstring, what is the standard and how to do it better. So that's like solution. I'm just giving you like a overview how it will look like. Next is like never stop. So we will put some cutoff mechanism, which also called like resilience pattern. If you see like agentic system design pattern, this is like a fancy name, but it means like we have to put some cutoff patterns, some max token or max budget, so that LLM don't surprise us and don't stuck into the infinite loop. So we have to kind of make some checks on that, right? Next is like malformed output. So again, it's more about like what the retry will look like, what the contract will look like. So we will talk about those into the like engineering section part, right? So now a toolkit. So we got a toolkit, but that isn't an agent. For example, we say like singleton, we like say prompt, and then LLM make some tool call, and then it's give you the answer. It's like a singleton. It's not an agent. So what agent is actually, if you see, one thing is missing, that's like a loop. So if you see in a real life, there is like, for example, I will give the example of the coding agent. So if you see, it's make some changes and like unit test fail. So it's again, so what happened, like its unit test failed, it's send the fail report to LLM, it give the response, make changes, it try again and it's fail, so it's again send the response and it do, and the loop breaking is like maybe it will try until this is like pass, or maybe it will try for 10 times. So if you see, actually the looping part is agent, and which make it difference than singleton assistant to actually an agent. We'll talk this more about like in our next episode, where what actually agents are, what are the different section of it. But for now, the simple answer is that loop actually is the agent, right? So as I promised in the video that I will do a postmortem of ChatGPT, and if you see, I show you a diagram of simple one side your machine, one side your LLM, and your question was, Sunny, but it doesn't make sense, because in the online, right, I just type response to like question to ChatGPT and give me a response. I'm not able to relate. So I will just break down the architecture. So actually what happening is, if in the web like version of AI, when we're using, for example, ChatGPT, there are 3 layers. Okay, so one layer is browser, where you are accessing it, and browser is a very thin layer, it's just like an interface. And then there is an OpenAI server, which is like a layer 2, and then there is actually OpenAI LLM, or the model, like the brain, right? So in our previous diagram, if you remember, where we talk about like your machines and the LLM, so we are talking about the layer 2 and layer 3, we are not talking about layer 1. And when you actually build the agentic system, you will mostly build the layer 2. Layer 3 is something we will just directly use from like Anthropic, ChatGPT, or Gemini. But layer 2 is something which we will build like most of the time. Layer 1 is just like an interface. I mean, for a specific use case, we might need to build our custom interface, which is okay. But layer 2 is the crux where we will actually spend more time, right? So if you see how this work, I will just quickly explain it. So when you open chatgpt.com and you type something, so it's make a HTTP request to a server running into the cloud, and it's take care about your authentication, your history, and everything. And then whatever you type, it just goes there, and it's make call to the LLM. And if there is like some tools needed, LLM first respond to server, and server will basically have this runtime environment you are seeing, where it will run like Python scripts or web search or whatever it's want. It will run the tools and make return response to the LLM running in the cloud, and it will form the response, and then at the end it will come to the browser. So it's like browser is a very lightweight layer, and things are happening inside OpenAI servers and the model. So let's like deep dive more, and I will show you the real demo how it will look like. Okay, yeah, so let's see like real time. So this is a browser, I am hitting ChatGPT, and it's right now open. Let me also open the inspect like network tab, so that we can see. And I will talk about like, let's ask a simple question: what is an NVIDIA price now? Okay, and let's see, it's doing searching some web, and it just give me whole chart, right? Let's postmortem this thing, how this happened, right? If you see there's a bunch of call happening, it sounds like very noisy, but most of things are basically HTML, CSS, and kind of telemetry. Let's go to fetch and XHR, and if I'm going here, prepare, ignore it. So this is the conversation. So this is the most important part. If you see, apart from that, all others are mostly preparing, or like the telemetry part. So this is the conversation, is the most important API call, and this is the only call where all our conversations are happening, right? So if you see like headers, this is like a simply ChatGPT backend API conversations, and payloads like whatever simple like my questions and everything is going. And if you just see something called interesting called event stream, what it is, so this is basically they are using server set instruction. Like basically what it is happening is, it's an one layer up. It's based on the like HTTP protocol only. It's not WebSocket. WebSocket is heavy. So here what will happen is, you make query to the web normally like HTTP protocol, but when like server is returning you the response, it return in a form of stream, right? So these are like a stream, and we'll deep dive it into the more, and we'll see how interesting look like. And but few things, for example, you are seeing like this delta, right? So what happening is like it send you something and then it send you delta, which basically append it like one by one there, right? So let's do one thing. Let's go into the response and let's copy this response. And I created a simple like HTML inspector here to inspect this and break down more, right? So let's go into the parsing. So if you see, the first is like first line is delta encoding format v1. So what happening is like our web client is doing a handshake with servers that okay, we will talk on this v1 protocol, right? And then there is a reconnect JWT. So this is like a resume conversation token. I hide the token directly, but what it means is like this is also very fancy things which happen with SSC log, that if any time your conversation break, like your network drop or something happen, your browser can reconnect to the server using this token for the same conversation. So this is also very interesting. So this is like after in the Web3 we have after introducing this SSC things, all like ChatGPT, Anthropic, Google, they use the same thing. They don't use the WebSocket, and this is really good for designing like current agentic chat kind of thing, right? So what it is doing is it is doing simply like it's handling the resume conversation. You can use this token and restart. And like system context is basically okay. One more thing, this is like hidden. If you see, if you query, this is like hidden from the conversation, which means there is a lot of context in our web is going, which is not actually showing to you. So same way, what we are figuring out here, there are two things. When I'm typing this, when I'm typing this, right? So there are like one thing which I'm giving the prompt, and apart from that, there are also system prompt which is going to the server, which is hidden. So we can learn from here that whenever we are designing a system, we also need to like have our own system prompt apart from the user prompt, right? So that is like one of the interesting thing. And rest is fine. And then this is like user way. I'm saying like what is the NVIDIA price right now? So this is the call going to the LLM that okay, what is the price? And LLM is input developers and blah blah. This is like assistant. Then basically assistant is saying like how to basically reply this query. And then a hidden system context. So this system context also came when they are sending the reply, right? How we will actually represent it. For example, if you see, it's represented in a very nice chart format, right? So front-end team basically send those instructions like how to generate the chart, or if there are specific UI you need to generate, right? So those also instructions came as a hidden prompt to the front end. Interesting part here is the tool call. So what will happen is your servers, like the model decided that okay, I need to do this tool call. And if you see here, this is like in web, which means like you have to do the web call, and it is running on the server, but as a thin client we are just getting a small log to be aware like what is happening inside the server. So LLM said that okay, let's do search. And if you see, this text is like search what is NVIDIA price right now. Simple look like function calling, and we will call web recipient with this. Next is actually executing it. And if you see, this will be like web.run somewhere, web.run. Yeah, this web.run is executing it. This is our runtime. So basically we got functions, we got commands, and now actually it is running where basically we are trying to find the search. And then this delta. So what this delta means is like server is keep sending new responses, like basically new data to the same conversation, so that either ChatGPT, either like a system prompt, or if it is a new like response, if you see chats are basically getting appended down the line. So this is happening. Again, system context, this will be a context for how to represent it and all. And there is bunch of these things is happening, and at the end like our data is coming and our chats are closed. So if you see, I break down here how ChatGPT is working. It's the same way. There are like bunch of prompts going to the like LLM, and LLM is basically responding with LLM is basically responding with the data or prompts, all the tools call, and then also this like assist thing, right? What happening is your actual web client is directly giving instruction to your LLM that give response into this format, and bunch of other things. So this is very interesting thing. But if you see, on an average, whatever we like studied from last lectures, like the tools calling is happening. If we say there are like prompt engineering where we'll select chain of thoughts and all those are happenings, and same way there is little bit like knowledge base also. This web client is giving knowledge about myself and few other data. They are like doing bunch of transfer here and there, right? So this was the real how ChatGPT works. Now the question is, what is an agent really, right? So as we talk about it, the loop is agent where we are simply looping through it, right? But it's very simple way of explaining it. Actually, agent is very there's a lot of things into the agent. So next chapter we'll talk about what agent really are, what are their multiple components which on a higher level which we need to study, and that will really set up a foundation for our engineering section, which is going to be in depth, and it will literally blow your mind, because this is going to be the things which you will really use in your real life, right? So thanks everyone. If you are still here, really thank you. Please do like, share and subscribe. This help and motivate me to make this chapters further, and see you in the next episode. Till then, thank you. Bye bye.